Yesterday we saw the complete explanation about the loan prediction code, which was the sample code of machine learning concepts. Now we'll continue with one more code, that is the customer segmentation. So it is in the same folder which I sent on the beginning days. So you can just get into that folder. So all of you can open that data set. I have kept it ready here. This is the data set of customer segmentation. And in this folder, two codes are there. Yesterday, I asked about like what was the difference between both the codes. Like in one code, the algorithm accuracy numbers was coming very less. In another code, it was quite different. Means the accuracy was improved. So I asked everyone, you can just go through with that and get back to me today, like what was the difference. So anyone noticed like what was the change in that? Can any member tell me about the changes done, or what was the problem identified in the first code? Any member check the code? Anyone of you noticed like in both the codes there was a difference something where the accuracy got increased in the second one. L2 was mentioned over there, level 2. Anyone of you are able to notice that what was the problem with the first code and or how that accuracy got increased?
Good morning, sir.
Yeah, good morning.
Some two categories of there were removed, sir, there from the previous two categories of workers were removed, sir, from the previous case.
Two categories were removed.
Sir. In the second.
Name that.
I don't remember, sir, sincerely. I think one is work home.
Okay, no problem, sir. I'll continue with the things. So I was just interested, like anyone have checked the code or not, or are you able to understand the flow of it and all? Fine. Anyway, I'll start with the explanation and I'll explain like what was the issue and all. Fine. Okay. So this is the second code with respect to complete machine learning concept. So whatever we saw with the loan prediction, similar steps we can find it here also. This is quite little improved version. Improved version means with respect to the learning, not with any accuracies and all, because all these codes are taken in the format of learning part. A simple data set has been taken because these data sets like loan predictions or customer segmentation, the terms in the means the column names or the parameters names are easy to understand. Means we can analyze these things because these concepts we have we know in our day-to-day life. So just I have taken this thing. So the first point what I am covering, like a new learning concept here, is I'm trying to cover some more algorithms here, just to know that how to use it. Okay. So algorithms from the same library we are using it. So here I am covering k nearest neighbor and SVM. So just how we have used the logistic regression in the yesterday's code loan prediction. Same way here with logistic regression, I am covering other two algorithms. So first we'll see the data set now. So again, this is a type of a supervised machine learning algorithm. When we tell supervised, there should be one parameter which represents the output class or a label. So this is my output class or a label, that is segmentation. The name of that parameter is segmentation here. And here by roughly observing this, we can see that some A, B, C, D like that class segmentation has been mentioned. Okay. So in the previous code, we saw only two types of classes, like a loan available or not, like yes or no, right? So here we can see like multiple classes. So here at least 4 classes are there, A, B, C, D, we can observe here, right? Okay. So first we are starting with the input now. So whenever you want to start with any machine learning project, first we have to understand the input. So manually we are trying to understand it. So here we have ID, some gender parameters are there. Again, marriage status and all is there with the shopping. Customer segmentation is basically with the shopping concepts it will be there. So some age and all, then graduation. So they are from which professions and all is there. Some work experience, spending, they have spent a low or average family members. So like this, we have some of the parameters. So now we'll get into the code part. So machine learning methodology, the first part is import libraries, right? So same libraries, the way of the method of writing the code, everything have kept it same so that we can understand the new concepts which we are trying to learn over here. Okay, the first part is the NumPy library, then pandas to read our Excel data sets. Basically, data frame we tell whenever you want to handle any data, pandas is the best library at present. Then to generate graphs and all, matplot and seaborn. Regarding machine learning library, we are using scikit-learn, sklearn. So in this library only, we have our function test and train split, then algorithms related logistic regression, K, neighbors classifier, we call it as a KNN, K nearest neighbor. See, NN, normally when we tell NN means in short form that relates to the neural network. But because in neural network, we get algorithm like CNN, convolution neural network, ANN, artificial neural network like that. But there is no relation with this KNN and with the other neural network methods. This is not with any neural network concept. KNN works with some different theory. Okay, it is not related with neural network at all. Only the short form is represented as a KNN. Then SVM means support vector machine. That is another type of algorithm. So even our accuracy we were checking, no? So that also is there in the scikit-learn. So all the libraries are done. So in the output screen, we find libraries updated. Okay, I'll execute this code now first. So the first graph has been opened here. I'll just rearrange my output screen and all. So in the output, we find that the statement library is updated. Then some basic initialize and all that part has been done. Next step is we have to read our input. So customer data set, our data set I am reading in my code now, pd.read CSV. So df is a variable. In df now I got all my content of the data set. Whatever the content was there in data set, everything I got into my variable df now. So next now through programmatic method, I have to analyze my data, which comes under the pre-processing stage. So multiple concepts comes in the pre-processing stage, and that is quite important concept part also, handling the pre-processing stages and all. So the first is like a shape, df.shape. When I call the shape function, so we are going to find the overall size of the data that we can see here. We have total 11 parameters, that is the 11 column, and around 8,000 data we have, 8,000 rows. Okay, then df.column means it's going to list all the column names in the output screen. Then value counts, I am checking with the last parameter, that is the output parameter now. So it is named as segmentation. So value counts. So this is one important step we have to follow in all the codes, and this step is done for different parameters also. Here I'm doing it for the last parameter. Last means for the output parameter. So first we have to see like output, how the data are balanced or imbalanced with respect to the output. Again, with respect to different parameters also, we need to do that analysis. Okay, so this one analysis is required in all the projects in pre-processing stage. So value counts, whenever I call value counts, it's going to give the total count of the type of data present in that parameter. So how many types of data present, right? So it's going to give the total count of it. So now we can observe like here it has been mentioned, and in decrement order it has been mentioned. So now with the output class name D, we have almost around 2200 data. So similar way with the output class A around 1900, C also 1900, and B also B is around 1800 something, right? So now total 8000 data has been splitted into these 4 classes. Now with the class A, we have around 900 data. So by observing this data, we come to know that our data with respect to the output class, it's quite balanced. Means all the output class related data are with more better relations. Means in a better ratio, sorry, not with the relation, with a better ratio. The ratio, like now if I take an example of a fruits, so whenever you are training the algorithm, you have a apple fruit around 100, then near to that another I have 78. It's not like one fruit you have 100 apple, and orange you have only 5. Okay, in that case, the orange training won't happen in a perfect way because the data is very less. Okay, even our child also same way, right? When we think kid. Okay, so whenever you are training related to the fruits for the kid, when you have a huge data means what? Daily you will be speaking about it. Less data means much information for the child so that it won't remember that. So same way here also, we have to consider our data in a the data has to be more actually. So and it's here everything is balanced. Now we'll get to the next one. Head 5 means the first 5 data I can see in the output screen, the first 5 data. So if you maximize and see, you can see it in a better format. These are the first 5 data. Then in the code I have describe. So describe means it's going to give the count of each parameter and some maximum value and minimum value of those parameters. So this is a describe one. So we can see our ID. So some 8600 sorry 8068 data is there. Age also same. In work experience and family we have less numbers. So here also some data contents are missing. So some cells are empty. Okay, that we came to know with this. And what is the maximum and minimum? Like age, if you consider, see we have a data with the age maximum of 89, and we have a data with the age minimum of 18. Okay, so all these things are helpful for our analysis. So we have to understand the data here. Using describe, few points can be covered. So after this, here this is one part which I have not covered in the first code. Delete. See, now some of the parameters are not required for your analysis. By observing my data, now I came to know like some of the parameters are not required. So in that case, I can remove that parameter in the analysis. So here the ID is not required for me. The ID number and all is not required for analysis. Here some var _1 something is there. And when I downloaded this data set from internet, I didn't came to know like what is the meaning of this parameter also. So that's why right now I'm not using both the parameters. So if any of your parameters are not required for the analysis, means then using a delete method, delete key, I can remove that parameter. Delete means in our Excel it will be there. All the Excel content I copied to the variable in my code, right? So there I am deleting it. So now for my analysis, the ID parameter and one more var _1 parameter I'm not using. So after that again I'm checking with the shape. Shape gives overall size of our data. Like now we have 9 parameters and 8000 rows is there. 8000 data is there, right? So before it was 11. If you scroll up and see, there were 11 parameters. Since 2 parameters we deleted from our analysis now. So now we have left with only 9. So the next step is check with is there any null content. Null content means the empty cells. So when I call df is null sum means it's going to give the total count of the empty cells with respect to each parameter. So we have some empty cells also here, so that you can observe it. So this is the data set. So we can find like ever married, related to profession, work experience, many positions, there are empty cells. So here I'm just using a drop in a function, drop in a when I use. So whichever the empty cells contents are there, right? The full data, the complete row will be deleted now. So again, I'm not using those data for analysis. So if you see here, there is an empty cell. So now this full row will be removed from the analysis. So I'm just dropping it. Okay. So in yesterday's code, even we dropped also, and in one or two parameters, we took the average value of that parameter and we replaced in those empty cells, right? So here I'm just going with the dropping method. So I dropped it. So wherever empty cells was it, the complete data, the complete row I had removed from my analysis now. So using drop NA function. Then again, I'm checking with the empty cells part now. Now you can see everywhere it is 0 because all the empty cell positions I removed it now. Then I'm checking with the shape now. So now you can see 9 parameters and 6,700 data we have. Before we were having almost around 8,000 plus, right? So now we are having 6,700 data for our analysis. So this is the data which we are using now to continue with the analysis. Then again, I'm checking with the value counts with the segmentation because I deleted more, right? Say from 8,000, I came to 6,700. So almost some 1,300 data got deleted, right? So I don't know with the same class it got deleted. And again, with respect to the output, our data should not become imbalanced, right? So again, I'm checking with the value counter of my output parameter. So you can see here with respect to ABCD, I have means with respect to the output classes like ABCD, I have in the ratios of 1,500 to 1,700. So again, our data set is balanced only. There is no problem with the data set with respect to the output class. Okay, fine. So some level of pre-processing got completed. So I'm just displaying like a pre-processing visualization level 1 done. Okay. So next some graphical view. So what are the graphical view I am doing it? It is similar to the previous method in the previous code what we followed. So now using Seaborn with respect to gender and ever married. So with respect to those two parameters, I am generating the graph. But in the previous code, I kept gender reference and I compared with output and other things also. So here right now, some two graphs I am checking. So if you go and see now. So this is the first graph. So in the code I had given save fix, so it will save in the folder also. This graph will be saved, plot show. So the graph has been opened and the code has been altered at this point only. Once I close this, the code will get executed for the next level. Now with respect to the gender and ever married status with the data, I'm able to see the graph. So with this graph, we'll come to know that with respect to the male gender and with the ever married, yes means they are married. Okay. So we have data almost around more than 2,300 or 400. That exact number also I'm printing on the output screen. We can see with the male with marriage, we have around 2,300. So the which one we have less? So roughly around without marriage and male and female both are almost equivalent. So less than 1,500 we are able to see. So that you can see with the female 1,400 and male with the 1,300, right? Okay. So I'll close this. Next, I'll get into the next one. See, when we are see, analysis means okay, I'll come back. I'll speak little theory part. See, when we speak about machine learning or data analyst field, data science fields and all, as we get into more complicated, as we start off analyzing in a deeper way, the things becomes much more complicated. If you just see in the outer, as an outer layer, it looks everything simple. Okay. So analysis means we have to put up questions for ourselves and we have to observe it. Then only we can see in a deeper way about all these contents. Okay. These data sets are for education level. The contents are very less, but in real time, the things are quite different. Okay. Like the previous graph, which I showed now with respect to married status. So with that, we'll come to know, okay, here with the female contents are coming more or not. If you consider related to one shop, this data is there. Okay. So which category of people are coming to your shop? So now you have to analyze. Now you are seeing that in your shop, you are getting with the age of around 30 to 40. So now you have to keep materials in that category, right? So that the what kind of materials are most suitable for the age of 30 to 40. If you are keeping that kind of materials in your shop, then the sales will be more because the shop where you are keeping the surrounding locality or the people who are able to reach you are in that age. So whoever is coming in with respect, whoever is visiting your shop, once you come to know the age of that segment, then you can maintain that kind of materials with good stock also, or you can increase the variety of that materials, right? So like this, these analysis are taken in real time. So the data should be huge, and the way we try to analyze also, it's quite different. So, and everything depends on how we see these things. Okay. So now we are seeing in the program as a programmer, like to get some results from a raw data set, how we have to write the code. Okay. So now the second graph here, gender with respect to the profession parameter, I'm drawing it now. So there is one parameter called profession. So I'm taking this and I'm drawing it now. So when you see this one, we are able to find more data are there with the different types of professions. Like here, how many, like nine types of professions are there, right? So this one again, counting in the Excel is not quite easy, right? So if I ask like in Excel, check out like how many professions are there, means you can't observe easily because 9 is there, no? So that's why again the graphical view gives better information. So, and second thing is, now we can see like with respect to which profession the data is more, and with respect to which profession data is less. So which profession data we are finding very less here? Can any one member tell me that?
Homemaker, sir.
Homemaker is very less, right? Then next,
Artist.
artist is very less. Homemaker in which gender it is very less? With respect to the gender.
Male it is.
Right? So here you can see that the yellow color bar, right? With respect to the male, the data is very less. It's almost near to zero. I can think like, see this unit is from 0 to 200. So I think it will be around 10 to 15 or 20 like that. So now we can see here the exact numbers also. So here the data is more, so it's coming with dotted line. So with the male, around 30 data we have, right? So now see, this is with the purple is for artist. For artist, the data is very huge, right? Both in the male and female, it is more than 1,000. Now we can tell like with respect to the profession parameters, the data is quite imbalanced right now, because see, one profession data is very high and one profession data is very low. Okay, and some professions are in the range of around 400, right? Some 4 to 5 professions. So if you are giving these kind of data, obviously the algorithm will get confused. See here, executive, you can observe in executive with the male we have very huge data, and with the female the data is very less, right? So some imbalanced contents we can find here with respect to the profession parameter. So this one point we can note down. So here we find out one problem with respect to the professions. There is a quite imbalanced data. Clear? So now I'll close this. Okay, so see, now it took small time to execute. Okay, after logistic regression, small time it took. As our data increases, different algorithms, it takes a lot of execution time also. When we get into the images and all this will take like 1 hour, 1.5 hours and all to execute the modules. Now I'm scrolling up the output screen. So all the graphical view part got completed. So after graphical visualizations, now I'm converting some of the string parameters into numerical parameters. That I did it in the yesterday's code also. So here also related to profession, then spending, gender and all, we have some string data. If you want, you can convert into numerical formats. So that part I'm doing here. So I'm checking now first with the gender part, male replacing 1 and female 0. So that you can see here. So this is the data we have with respect to male and female. So that has been replaced by 0 and 1. So that I'm applying for all the parameters where I'm finding the string content. So now you can observe for the profession also. So profession part. So related to artist, healthcare contents are there. So I had given a number from 1 to 9. So when I'm assigning a numerical format, I'm just formatting the I'm just considering the alphabetical order. So A for come first, so 1, D, 2, 3, like that I had assigned based on the alphabetic order. So now we can see here. So by this we are coming to know that with respect to the artist, we have almost around 2000 data, and with respect to the homemaker, we have very less. Homemaker and marketing, the data are quite less. So my pre-processing stage and all got completed. So I completed with splitting the data now. So till now, what all I did in the pre-processing stage, I deleted some of the parameters which were not required. The empty cells I removed, the rows contents. Now wherever the empty cells I found it, the complete row only I removed from the analysis. So that I did. Then with graphical visualizations, generating some graphs, I observed my data. So in that we came to know one problem with respect to the profession parameters. There are different types of parameters also, and few parameters, and the data is quite imbalanced over there. Okay, with respect to one or two parameters, the data is coming quite imbalanced. Okay, then I did all the replacements with all the strings data. I replaced it with a numerical value. So up to this has been done. Now next step is, so I completed my pre-processing stage. After pre-processing, next what we have to do? What is the next step?
Training and testing the data.
Yeah, so we have to split our data for in the format of training data and testing data, because now whatever this data I have, I need to pass to the algorithm. Then to check the algorithm, how it is performing for with respect to my training data, I have to keep little bit less data for testing purpose also. Okay, so now we are having almost around 6,700 data, right? So that I'm going to use it now. So I'm dividing my data into input and output. X using ilog function, I'm passing all the input parameters to the X, and using ilog function, the -1, that is the last parameter, I'm passing to the Y variable. So right now I'm taking two variables, like so X is going to have all the input parameter and Y is having the output parameter. Clear? Okay. So next, test and train split function. So all these coding methods, everything is same with the previous code what we saw yesterday. Okay. So test and train function, my input and output I'm passing. I have decided test size as 0.1. We can change this also, instead of 0.1, 0.2 and all we can make, and we can see that. So test size I have splitted. Now I kept 90% of my data for training the algorithm and 10% for testing the algorithm. So once I pass my input and output data to this function train test split, it's going to return the data in four format. One is the train X, test X, train Y, and test Y. So train X means your input portion, that is the 90% of my data. So this is my input portion, right? So input portion, 90% of the data is kept passed to train X. So similar way, the output portion, that is the 90% of the data, that is the train Y. Then test X, only 10% we kept for testing. So that 10% data, that is the test X input portion. Then output portion of the test data, that is the test Y. Okay, so now my data got split into four parts. So all my data content I'm printing here now, just for observation. So you can see now. So this is my train X data, almost around 6,000 it is coming. Total we were having 6,700 something. So the 10% of the data, that is the test X, it is coming around 600. Okay, so 6,000 data we have around for our training, and around 600 data I am having for testing. So all the row numbers we can find here, everything is shuffled. Okay, in a random format, it's going to shuffle and it's going to pick up. So it's not picking the data in any order and all. Then similar data with the train Y. So that is also train Y. So training data around 90%, that is 6,000 plus is there. And test data, that is the 10%, around 600 we have. Okay. Now next, even 10% of my testing data is almost around 600 plus, right? So all 600 data I can't test it. So tough to see, analyze those outputs and all. So I'm keeping only here 10 data. So from my test X, I'm just taking 10 data and I'm passing it to the function final test. Only 10 data I'm taking and I have passed into the final test function. So that also I'm just printing on the output screen, so you can observe here. Okay. So all these steps I did it in the yesterday's code, same steps, nothing I have changed it here. The way of writing code, everything is same. So now my test and train split part got completed. Next is the logistic regression algorithm I'm using. Same algorithm I used in yesterday's code also. So logistic regression I'm calling. This algorithm is there in the scikit-learn library. So I'm just activating my algorithm in my code now. So the model, and I'd given a short form as a LR in my code. LR.fit. So when I'm calling the fit function, I have to pass my training data. So I am sending my training data to the algorithm. So you can see that train X and train Y. So what all my input parameters was there, for that input parameter, the respective output parameter, both are splitted and kept it in the training data. So that I am passing to the algorithm. So now algorithm will do all the analysis internally. I gave my data to the brain, so it did the analysis. So it took all the input and respective outputs. So now the algorithm is ready. So next LR.predict. So when I am giving calling the function predict, I have to pass my test data. For this test data, so here how much we are having? 10%. That is around 600 something we have, right? Test data. So that complete 600 data I'm passing for algorithm, and I'm asking it to predict it. For all this test data, it is predicting and it is giving the output for me. That output is there in this predict variable. Now to check with the accuracy, I am checking between our output and with the predicted output. In test Y, I have the output of this test X, right? For all 600 data, what was the answer that I am having in a test Y? And when I pass my test X data, the input data for the algorithm to predict, it has given the output. That output and our known output, both I am giving for the accuracy score function. So it's going to reply the accuracy that we can check here now. So this is the LR algorithm accuracy. So you can find here, it is coming almost around 49%. So less than 50% accuracy we are finding, right? So less than 50% is very bad, right? So the algorithm prediction will be more wrong now because the accuracy is very less. So now next here, so to check with the outputs, specific outputs and all 600 data very tough to see, right? So that's why I kept only some 10 data in the output screen. Only 10 data I passed it to the final test variable. From test X, only 10 data I took there. So that 10 data I am passing again to the algorithm to predict. So that output it has given here. So that output I am printing in the output prediction. So this is the output prediction of the 10 data using logistic regression algorithm. And I have to compare it, no? So whatever the known output was there, that is there in test Y. So there also some 10 data I'm printing it. So this is the known output. Okay, now we can cross check. The first output was supposed to be telling like with the segment 2, but here it is answering 3. Second one was supposed to be 1, but it is answering 4. And third one supposed to be 1. So here 2 it is telling. So only the fourth one is correct, right? Fourth one. So you can see at maximum position, the predicted result is coming wrong, right? The reason is the accuracy is very less. Clear now? So this is with the logistic regression. Now see, next I am getting into the another algorithm. So with logistic regression, the accuracy came very less. Now I am trying with another algorithm, that is the SVM. Okay. See, the code for logistic regression and SVM algorithm, everything is same. We have just making use of the library here. In the library, we have the algorithm contents. So how to use that part we are following. So to call SVM, there is one method like svm.svc, something we have to mention. So for that, I had given a reference variable name as a svm underscore model. So this is my variable name which I had given. You can give any name over here. So then again, I'm calling the fit function, same to logistic regression. So fit function. So when I'm call fit function, I have to pass my training data. This is another algorithm, like another brain. Okay, assume like in front of me, 3 people is there. One person name is logistic regression, one person name is SVM, and one person name is KNN. So I'm just calling the first person logistic regression. I gave my all my data. Just think like all this data is like a chip. I just inserted the chip in his body. So he got trained completely. And when I give my testing data, he's going to give some answers for that. Clear? So same way, Now I'm calling the another algorithm, SVM. svm.fit. So my training data I have passed over there. So now the SVM algorithm got trained with respect to my data, right? So now I'm asking the predict. Same methods, predict here, what you're finding, same method here also. So when I'm calling the predict test text, so I'm passing my input data, all the 10% data, the predicted answer is here. I'm cross-checking with the accuracy. To check accuracy, what was our data answers for the test text, test Y was there. This is our stored answers, and this is the predicted answer from the algorithm SVM. So when I check the accuracy, you can see accuracy for SVM, it is around 46. Still it is less, right? And again, I'm checking for the predict for final test, the 10 data. So that also I'm printing here as a output P. So this you can see the predicted answer for the SVM. So compared to this, so this is the actual answer and the SVM predicted answer. So we can observe here also at many positions, the prediction is wrong, right? So next I'll get into the another algorithm, that is the KNN, K nearest neighbor. So K neighbors classifier I'm calling, and I'm assigning a variable name as KNN model. KNN model dot fit. When I'm calling fit function, pass your training data, predict, pass your testing data. The predicted answer is there. Check with the accuracy. So accuracy I'm testing with my answers and with the KNN answer. So here also the accuracy you can find as 47. So here also there is wrong, right? So means the accuracy is very poor. So then predict for my 10 data. So it is predicting that 10 data, that also you can see here the answers are coming. All answers are almost wrong. Only few are correct with the correct answers. Clear? So project ends. So the code got completed. So here what we find it is we used different algorithms in this code. How to use and all we came to know different algorithms with a machine learning library using sklearn. And in this code we are finding the accuracy is very less. Now I'll do one thing. I'll try to change my test and training ratios. Let me see that with that any changes happens. So instead of 0.1, I'll do it as 0.2. 0.2 means now 80% for training and 20% for testing. So I reduce my training data content. Okay. So making it as a 80%. Before it was around 50%. 90%. So you can see that, see here, it is taking small time to run with SVM. So still it is on the same range. There is nothing like much difference, right? Okay. So next, now I have one more code where I'm trying to solve this problem. That is with this in the same folder, you will find a code customer segment L2. So all of you can open this code also and you can run it now. Till now, whatever I explained, if anyone is having any doubts, you can just clarify so that I'll continue with the next part. I'll wait for 2 minutes and you can just clarify it. So I request all members to just go through with the level 2 code also. You can open the level 2 code in your system. Any doubts are there, you can clarify. After 2 minutes, I'll continue with the explanation. Okay, now I'll continue with this code now. So now we'll see like what we can do so that our accuracy get improved. Okay. So now this is the say another code customer segmentation L2 is there that you can check now. So I had executed and I kept this output here. So the libraries, everything is same. So I'll just explain which part I have changed it. Okay. So libraries contents, all those are same. Then I'm reading my data, everything that is correct. And here I've deleted some parameters. Then I'm deleting some of the rows where the empty cells was there. Then graphical visualization, the first graph and the second graph. So here I mentioned a comment like a code added to improve accuracy. Okay. So now we'll see this. So the first graph already got opened. So this is my first graph and this is my second graph. So here we identified one problem, right? That was like what with respect to the profession parameters, the data is quite imbalanced right now. So now we'll consider this one and we'll try to see like by doing some changes in this parameter, are we able to get the accuracy better? So now coming here, just a moment. Okay, I'll close this. See, yeah. So in these parameters, I have one profession and another one is graduations, right? Normally for shopping related activities, graduation, anything makes any big difference. So I'm thinking that here related to shopping profession can give some difference because based on your professions, we select some of the products to use and all that is there. And one more thing is like even based on the professions, we can identify on an in an average way their earning or the positions, all those things can be identified. So some products specific things can be decided with a profession, but based on the they are graduated or not graduated, much things are not there. And after graduation your profession things will come into picture. So I am just generating one more graph which is related between graduation and professions here. Okay. So this we have to do whenever we do these kind of things in real time. First we have to check with the heat map. Heat map means heat maps will give the relation between all the parameters. Okay, 1:1 relation, the permutation and combination method it will give. So after that we can, wherever you find like okay these parameters are interrelated or I have to cross check these parameters, then you can start up doing some visualization methods between those parameters. So right now I have selected two parameter here. One is graduation and another one is the profession. Okay. So both I am going to correlate now. So for that I have generated one graph. So in this graph, what we are finding? Again, the artist content is very huge, right? So here you can see with the profession no and yes, right? So the graduated and yes, so no means they are not graduated. So this much data I have related to no graduation and this much data I have related to graduation. And here all the data are quite balanced because everything is coming below 500 almost. So somewhere around 250, 300 I'm getting. Only with the artist, the data is very huge, where it is almost around 1,800 or 1,900. Okay. Now, so I'm considering graduation level is not required for this kind of output. So I'm just trying to drop one more parameter now. Okay. So they are graduated or not graduated. For my product segments or for my analysis, it is not required. Later again, if it required means you can add it. Okay. Right now I'm taking that kind of decision. So and I'm removing one more parameter, that is the graduated. So now I removed the graduated parameter. Clear? So you come to the output screen here. Okay. So now I'll close this. The code has been altered at this position. Okay, plot show. So I'll close this. Once I close, the code got executed till end. So I'll go up. Mm. Just a moment. Okay, so I deleted my graduated parameter, right? Then what I'm doing is again I'm checking with the profession with the value counts. So previously explained, like even in the profession, few data are very high and few data are very low, right? So it was imbalanced. So I'm checking with the value count now. So with respect to the artist, the data was more, right? So using this index, I'm taking one variable reference. And I'm dropping the data related to the artist. Just a moment. Okay. So what I'm doing is right now I'm just dropping it, but in real time we can't drop any specific parameter content, only the type of data. So if you want, you can reduce different steps can be added. But here I just want to show like doing some steps, our accuracy can be increased. Okay. So what I'm doing is I'm removing one of the data content related to the artist in profession parameter. So using drop function, so I'm removing artist and I'm removing the homemaker also, because artist content was very high and related to the homemaker, the data was very less. So one with the very high data and one with the very low data, both I am dropping it out from the analysis now. Okay. So after that, I'm checking with the shape. df.shape means it's going to give the rows and columns. So now we have only 4,300 data for analysis and 8 parameters are there, right? Okay. After that, again, I'm continuing with the remaining steps, which I did it in my previous code. So I had replaced with some numerical values, all those things. So then I'm splitting my data. So you can scroll down. So all the other steps are same. Now we'll get it to see the output now. So remaining every step is same. Just to understand, I had written in the comment over here, code added to improve the accuracy. So I removed one parameter, and then in the profession parameter, I removed all the data related to artist and homemaker. So after doing this thing, now we can check the output here. If I scroll down fully on the bottom, so now we can see that accuracy got increased with respect to logistic regression around 86 it is coming, and SVM around 69, and KNN is around 79. Now we can compare with the outputs also. So with the output of a logistic regression, the first output was supposed to be 3. Here also we are getting 3. Second one also is correct. Third one is wrong. Fourth is correct. Same way you can check here also. Even in SVM, the first one is correct. Sorry, second one is correct. And the fourth one is correct. So in some places we are able to find some correct predictions. And again, some places it is wrong because still the accuracies are around 60 or 80% like that. But wherever you find like more than 80% maximum positions, we can find the correct answers. So all members can check these things. If you have any doubts, you can clarify. So in this code, I tried to explain about how to analyze the data so that you can improve your accuracies and all by doing with different methods. So one step we followed here so that we saw some accuracy change. So this is the second example with the machine learning application. So if anyone has having any doubts, you can clarify so that I'll continue with the next topic.
Sir, good morning, sir.
Yeah, good morning, sir. Tell me.
Sir, this is from Ramkrishna Reddy, sir, Triple Department, sir, Government Polytechnic, Narpala, Andhra Pradesh, sir.
Okay.
Sir, artificial intelligence can be implemented for fault analysis, sir.
Font.
Fault, actually, you have a, suppose Anandapur, Bangalore, 200 kilometers, sir. So in between, there will be a relays are there, as per electrical terms, sir.
Relays. Okay.
Relay means it will recognize the fault whenever it exceeds the limits. Suppose it is designed for 5 amperes, so it exceeds 5 amperes. Relay will give the signal to the circuit breaker to open the that is about the circuit. So that is about present is going on, sir.
Okay.
So can it be implied that is about the artificial intelligence to that relay?
Yes, sir, it can be done. See, artificial intelligence can be applied for any field. okay, where already some automations are there. And this will be like future level discussions, because right now, whatever the processors or microcontrollers we have, they are still
Sir.
not up to mark to execute these kind of huge data.
Sir.
Okay. So in real time, the data will be in lakhs actually. Okay. So, and how much accurate data we have, according to that, the algorithms and all works in a better way. Fine, no? So when we give huge data to the algorithm, the model will become much more complicated one. So in future, we'll find these things, and in every automation field, wherever we want some decision should happen automatically, we can apply this AI and ML concepts.
Sir, sir.
Okay. In every
Thank you,
field.
sir. Because of network issues, we are unable to connect to you, sir, continuously.
Okay. Right now,
So,
what the industry is doing is, industry right now it is collecting more informations. They are collecting the data. Even IoT device, when we tell Internet of Things, in real time with
Sir.
sensors, all those things, you collect the data. Now all our Googles, the apps, whatever we are using, everything is collecting our data. Okay. So
Sir.
these data are, the companies are analyzing this data, and they are trying to build better modules and all. But there is one challenge with respect to the processor speeds. Right now, whatever processes are there, they are not still up to that mark, so that they can execute in a very huge data and all. Only the companies they are having with the very high end, but in the common market, in the local market, consumer fields and all, everywhere we are not getting that high end process with a very less cost.
The
But
operation should be milliseconds, sir. That is the problem, sir.
what's that?
Operation of the relay should be less than milliseconds, sir.
No, that will happen. See, sir, how it will work, I'll tell you. Now we first, by passing our training data, we made a model, right? That model can be saved as a single file. That file you can insert in any real-time applications.
Sir.
Data to see, this whole machine learning works in three parts. First is collect the data and do some data cleaning in that. Data cleaning means when real-time data, when we collect, no, there will be a lot of mistakes. Like if I ask someone to fill the form, someone may do spelling mistakes, someone unnecessarily they may fill some unwanted data over there, someone may fill wrong data, or they leave data blank. So many things are there. With the lot of garbage data, if you process your if you give to the algorithm, again the results will be much more with the garbage contents. Okay. So there is a one big step will be involved. That is the main job of the data analyst, where they have to clean the data and get it with some right usable method. That is the first step. Second step is, with respect to this data and what output we want, you apply all the machine learning algorithms and build a model file. That model file will be a single file, like some backend file will be there. That file you can insert into any real-time chip which can perform according to your data. Example, if I tell, if we have seen the movie Rajnikant Robo film, so to make that robot in a negative way, they show that they just inserted one chip inside that robot body, so it started in a negative method. So why that one is, they're having one chip, that chip is trained with all the negative data. So once you insert the machine will work for that. So like our brain, if you think like, if I train the brain with fruits, it will give answer for the fruits. If I train the brain with animals, it will give answer for the animals. So initially the brain will be empty. That training you can do it in some other computer. Okay, you train it and you get it one final module. That module you insert for the real-time product. So the real-time product already got the algorithm with trained informations, everything in a single file or a chip. Then it takes the real-time data for the predictions. Means the whole project, if you see, whatever my pre-processing stage is there, right? Up to that is one different task in real time in the companies. That is totally a different task, all the pre-processing stage. And after pre-processing stage, my test and train split and building the model and the algorithm up to here. This fit function is there, no? Up to here is another stage. After this fit, with respect to our data, the algorithm is ready. You can save it as a single file. We can do that step. Once that is done, this prediction is a separate step. This you can take it for any real-time environment. Once you trained it, so for that trained algorithm, you give the real-time data for it to give the answers for it. Means that answer, according to that answer, the next level decisions will work in real time. So this is another part. So the whole concept, what I explained in a simple way here with these examples, can be splitted into 3 categories of work. One is handling the data in the pre-processing stage, then build the model as per your data. We can configure this model also. Like logistic regression, there are a lot of parameters will come where we can configure it. Logistic regression, sklearn, if you go and see here. See, the model logistic regression is having so many parameters here. You can configure it. Whenever we are not configuring it, we are just calling that algorithm, means everything works with some default value. But if you want, you can configure this model also. So there are a lot of parameters. According to that, I can pass my conditions so that it get configured. These kind of configuration I'll explain in convolution neural network. A simple configuration steps also I'll explain that. Here we are not configuring anything. Everything we are just working with the default value, because our intention as a beginner level, first we have to learn how to use it. Then in the later stages, we can see some configuration that I'll explain in the CNN method. Okay. Any other doubts? Okay. So now I'll get into the next part. Okay. So now all members can open the one more code with the watermark. So if I complete this, my first content which I sent with respect to course materials, say FTP for course materials, all the code explanations, everything I completed. Now we are left with only one code. So that I'll complete now. Watermark. Again, this is a simple image processing code. So all of you can open this. So everyone knows about the watermark, right? So whenever any documents are there, you can put your company name, logo in the watermark format. So it will be like a hidden one in a very light format. We can observe it. So first I'll run this here. So you can see one output folder is there. The folder is empty. Okay. And there is one image or one input folder is there. So where we can find small images here. So there is no name or any watermark mentioned in these images. Clear? So I have kept some 3 images here. Okay, fine. So now I have one logo here with my company name Pragmatic. So now I'll put when I execute this code, the logo will be replaced in those images. So we can see that will be added as an watermark. So I'm executing the code now. So you can see like project and came. So now I'll get into the output folder. So now you can see that before this output folder was empty. So right now output folder is there. Now we can find the whatever the images was there in the input folder, right? Same came in the output folder with the watermark here with the company name Pragmatic. You can see here that I kept it separately logo there. So you can see that name has been added here as a simple watermark method. These are all small simple codes which make us to understand much more better with the image processing and Python programming. So all members can execute in your laptops also. If you're facing any issues, any doubts are there, you can just clarify. Within 2 minutes, I'll explain this code now.
Sir, good morning.
Good morning, sir. Yeah.
Sir, how can you add invisible watermark, sir? Invisible.
Just a moment, sir. I'll update.
Okay, thank you, sir.
Sir, can you repeat your question?
Sir,
Ah.
so I want to suppose I will draw one art, sir, one art. That art has to be secured by using invisible watermark.
Okay, that I'm not covering here. I don't have code for that one. So just for explanation purpose, I selected this as one code.
Okay, sir. No problem, sir.
I
Please
don't have
select, sir.
any
We will
code
try.
for that one. Yeah. For invisible watermark, yeah, I came to know your requirement.
Invisible watermark, sir.
Right. So in image
Yes.
processing, those all comes into picture. But right now I don't have that code, sir.
Sir.
Okay.
Okay, sir. No problem, sir.
Yeah.
We'll understand, sir.
Okay. Fine. So you can see this output. Now I'll continue with the code explanation. So the first part is the library. So all my image processings are done with OpenCV library. So OpenCV, then NumPy, then Globe and OS. So these two are related to the computer related activities. So right now I'm accessing my files, right? See, this code is quite generalized. It means you can keep n number of images in this folder. Right now I kept 3 images. You keep 10, 20, 100, whatever. So for all the images, it will add a watermark and it will show on the, it will copy it into the output folder. So I am accessing my data from one folder, taking there and add a watermark image, and I'm putting it into the another folder. So I'm doing some work related to the computer operating system, right? For those activities, these two library packages are required, Globe and OS. See, related to this library packages, if you're getting any error, then same method what we followed of installing the library packages, no? Same method can be followed. Go to the C drive, Python 3.7, then scripts. Then in the command prompt, we have to type pip install with the package name. Okay. OS is a built-in. I think for Globe, we have to install. Just check it out. If you're facing the problem, just install this package. So it will pop up an error with the package name only. Still any problems are there, you can send that error image and all for me. I'll try to solve it. Okay. So now I added all the required libraries. Then I'm reading my input image, that is the logo image. I'm reading it. So here I have the logo image with the name Pragmatic. So that I'm reading now. So then I'm finding the shape of that logo. So shape means it's going to give the overall size of that logo. So shape function we use for our Excel data set where it's going to give the total number of rows and columns, right? So here for that image, what is the size that it is replying? So we have some 79 rows and 600 columns are there, right? 608 columns are there. Okay. So I came to know that I'm mentioning as the height and width of it. So that I'm just printing here. So you can see on the output screen. So here the concept is very simple. There is nothing like much more complicated in this. So what I'm doing is I'm just taking one input image. So this is the input image, right? I'm finding the size of it and I'm finding the centering of it. Then your logo also, I got it. Both the centers, you just replace it. So in middle, you're getting that logo. Just I'm going to mask it or add it like that. Some steps are there. So I'm doing that one. So first I found out the size of my logo image. Then using a globe function, I'm reading all the images in the folder images here. So I have one input folder with the name as images, right? So in that one, star dot star, it means like it can be any file name and with any extension also. Extension means for images, it will be BMP, JPEG, JPG, JPEG. So those all comes as a file extensions for the images, right? So here star dot star means it can be any file name also, and any file extension also, which is there inside the folder images. Take all those references. So all that content came into the folder images path. Okay. Now adding watermark. Now for loop I am taking for one variable I have created in the images path. So now here in this image path I have total 3 data, right? 3 images are there. So I am reading the first image now. I am read. So I took my first image. So the first image size also I am identifying. So using shape, that size I am printing here as a height and width. So you can see this. This is my first image size. Clear? So next what I am doing is I am doing it's a simple steps here, nothing much more complicated. So I'm just finding the center of it. To find the center, half of your height and half of your width. So I got the center of my first image. Okay. Then I have my logo image, that also center I am finding it. Okay, both the images center I found it. Then I'm just adding those things in right positions. Then add weight, when I'm doing the add weight and all, both are getting added. After adding all the images now, sorry, the first image, what I'm doing is with the file name, with the keeping the same file name path and all, I am writing that image into the output folder. So output folder mentioned as a watermark with the previous file name. So here the file name was like 1, 2, and 3, right? So that I'm taking and I'm just replacing with the watermark text with the same file name 1, 2, 3. I'm replacing in the output folder. So using I am right. So this step is getting repeated in the for loop for total 3 times because I have 3 images. Once all the 3 images are done, it's going to come out of that loop and it will print like all added watermark added to all the images and project end. So all the 3 input images whatever we have, that size we can see in the output screen. Since the for loop is getting repeated 3 times here because 3 images are there. So here you can keep 4, 5, 10 a number of images. For all the images it's going to work. So all members can check the output once in your systems also. If you have any issue you can update me. So there is one more code here, add watermark top. See, these are some very simple codes and nothing like complicated steps has been followed here. Watermark can be done with a lot of complication methods also. Actually, these are some basics level codes. So now here what I'm doing is now I'll run this code now. Add on top something is there. So I just change the position in this one instead of adding it in the center. The small position change has been done. So I executed this code. Now go and see the output. So if you see the watermark, previously it was on the center, now a little bit on the left top side it has moved, right? So you can find like it has moved on the left top side. So what I did is here instead of taking the original image, see all the steps are same. The input image was there, no? Before I took the center by giving divide by 2. Instead of that, I had given divide by 3. So it is coming at the 30% position of it. So in that position, remaining all steps I am doing same. So it is getting replaced a little bit on the top side. So instead of divide by 2, I followed divide by 3 there. So instead of center, it has moved on a little bit on the top side. You can find here. Just a small change I applied over there. That's it. So by this I completed all the contents of in this folder. So again in the next afternoon session I'll be starting with the Anaconda Jupyter part. Yesterday I told about downloading steps of Anaconda and installation. Did all the members downloaded and installed the Anaconda?
Yes, sir.
So in
Yes,
the yes, right, okay. So in the afternoon session I'll be starting with how to work with the Jupyter codes. Here some Jupyter sample codes are there. So I'll explain like how to open that, and we learn how to use the Jupyter software. So that is the another software, like how we had IDLE now, right? So same way with Anaconda package, we get one more tool, Jupyter. So there we'll see like how we can write the code and how to execute it. Okay. So that I'll be continuing with the afternoon sessions.
Shikhan, sir.
Yes, sir.
Sir, mugita sir in the session.
Nan part complete agide. Ena doubts idre clarify ಮಾಡ್ಕೊಳ್ಳಿ.
Okay, okay.
ಅದನ್ನ mention ಮಾಡ್ದೆ.
Sir, excuse.
So like now the next session from 11 o'clock, Rakesh is going to continue.
Yeah. Now, Rakesh sir is online.
Excuse, sir.
Yeah, Rajkumar, please.
Shashi, sir.
Yes, sir.
How to start a project from scratch, sir, in our regular work, sir?
You are asking about machine learning.
Overview on scope and future of AI
Yeah.
with respect to industry view for the today's session.
Yeah, thanks for the invite for the whole team.
It's our pleasure. Now it is my immense pleasure to introduce a passionate professional for today's speaker, Sri Rakesh Nataraj. He is presently working as a software system senior test engineer in Dell Technologies. Earlier, he has worked in Nokia as a test team lead, senior test engineer, and in Synchronous Technologies as a software test engineer. He has 6 years of testing experience in the telecom domain, working actively in the SDM domains 4G and 5G, and is analytical, solution-oriented, positive, and energetic. He is passionate and committed towards work completion, results-driven and client-focused. And he is automation engineer with a demonstrated history of working in the telecommunication industry, skilled in Python, robot framework, shell scripting, test automation, and JMeter. Sir has expertise in AI ML concepts, hands-on with implementation within the project in Nokia, around 4+ years of experience in Python automation and robot framework, good understanding of network concepts, protocols, and OSI model layers, experience in writing libraries and scripts in Python using OOPS concepts and robot framework, hands-on experience with protocol simulators, hands-on experience in setting up of lab, installation of large-scale test bed, developed scripts for automated installation, hands-on experience in API testing, Python scripting and shell scripting, experience in CI, Jenkins job configurations, good understanding of automation lifecycle, develops methodologies and quality process, hands-on experience in Selenium and performance testing, good understanding of tools like Ansible, ELK, GIT to support automation and monitoring of the system. He has received Lab Transformation Award for bringing up large-scale testbed Nokia in the year 2019. Employee Award for the quarter Nokia in the year 2018. Your expertise and knowledge will be of great help for us, sir. Thank you for accepting our invitation and being part of this workshop as a resource person.
Thank you very much, sir, and thanks for the warm welcome. So maybe I can maybe we'll take a break or we'll start now.
Yeah. Okay, sir. So all the participants take 5 minutes break. After immediate 5 minutes, sir will overview on AI and MI with respect to the industry view. Once
Okay,
again,
sure.
thank you very much joining with us, sir. Thank you.
Thank you. Thank you for the opportunity as well.
Thank you.
Hello.
Hi, Rakesh. You can start the session now.
Okay. Okay. Sure. Thanks, Shashi. And
You have to share your screen, right?
yeah, I will.
Vishwanath, sir?
Shashi, I will make him co-host. 1 minute.
Right, sir. Okay, fine. Thank you.
Okay. And good morning, everyone. So thanks for the very warm welcome here. So it also gives me a great pleasure to share the knowledge whatever we have gained over the years of experience we have worked. So what I'll be going through today is so as Shashi has already covered the basics and the coding part of the AIML. So today I will mainly be talking about the AI and ML use cases in the industry and like in the latest like technology what are being used, where all the AIML is being used, what is the scope of it, and how can one be like ready to uh, to understand and explore the different aspects of the AIML. So these are the topics which I would be mainly covering today. So hope you can see my screen.
So visual, sir.
Yeah.
Yes.
Okay. Okay. So I'll skip the introduction part since Shashi has already covered it. So maybe the first use case, maybe I'll start with the spam email detection. So that is one of the main AI ML implementation that is mainly used in the Google Gmail and the Yahoo Mail also. So, I mean, why this spam email detection is needed? So basically, there are like multi ad companies that are waiting to steal your emails, and basically they try to send you like a spam email, and if you click it, maybe or, I mean, you can lose your money. You can they can take up your account number or the other details. So this kind of things is like a continuous process wherein that is happening very frequently these days. So for that, this AI ML has helped in like when we implement a particular model using this AI ML. So basically, what is AI ML? First is, so we have something like if something happens, there was an action that needs to be done by the manual intervention, that is by the human itself. But instead of acting every time, instead of a human acting every time, what if the machine itself can decide if something has gone wrong, maybe it can be corrected by this way or it can be prevented by this way. So that is where this machine learning came into picture to avoid the manual intervention, so that the system will be available 24/7, and if something happens, it is trying to recover on its own without any intervention from the external humans. So that is the basic intention why this machine learning was introduced. So for example, this spam, even, I mean, we have an option. If we get a spam email, we can mark it as a spam by manually, or some of the emails, Google automatically detects it as a spam and automatically moves it to spam folder. So this how it is learning in the backend is through some algorithms. So algorithms is the basic or the main source of this machine learning. So you decide, so whatever the output you want to achieve, and based on that output you want to write some code, and you want to make the machine learn whatever you want the output to be. And if something happens, if it needs to recover, how all it can recover. So all the things you have to train this particular AI ML code. So that is where this algorithm comes into picture. So when we'll start with the spam filtering example. So basically, spam is an email which we don't want to receive, and it is not an value add to our daily need. It is just something which we don't want. So for example, for spam detection, there are multiple ways to detect and filter out the spam emails. One of the like method is like for example, we can take a particular Gmail which has many emails from different users, like with different username itself is called a label. So first, like this is a general learning process in the machine learning. So this is the real world where this abundant data is present, and there are some measuring devices. So this can be either sensors, cameras, or databases, or anything that can measure a particular data. So once the data is captured, once the data is captured, we apply some mathematical algorithms to it, because this out of this huge data that is captured, so we only need the useful data, because again this classified and unclassified data will come into picture, because we don't need all the data, all the junk that is there. We try to extract what is only needed through some mathematical expressions, which will only give us some meaningful data. And that meaningful data based on, so like while extracting this particular data, so this is a part of pre-processing, wherein you extract this data and then you filter out this noise. Noise is something which we don't want in the data. So for example, if there is a CCTV in a signal light, and you want to capture who is not wearing helmet, so there should be a model which should only detect whoever is not wearing helmet. If it starts if the model starts capturing whoever is also wearing the helmet, it is no, it is a kind of not useful system, right? So that is where this pre-processing will only filter out whatever the uh, useful data we need, and whatever we don't want is considered as a noise, and it will be filtered out. So the feature extraction is, in this example, to detect an email or to detect whoever is not wearing the helmet. So this is the features, whatever the output we want or whatever we want the system to behave, this is called as a feature. So next process is called as dimensionality reduction. So here, so whatever the useful data, you have some useful data which you have extracted from the real world, and that data you want to present it in a graphical picture form, so that you want to see the graph out of it and see where the deviation is happening, at what point there will be a kind of curve that will be through that we can derive a kind of breaking point or a threshold point. So that point is derived here. So based on that, whatever uh, breaking point or the throughput we find it here, or threshold we find it here, so that will be kind of a key value for us. And then we start training the model. So training in the sense, we already have a code, so that code has to behave in a particular way when a particular thing happens. So that particular value is derived from this graph, and based on that value we try to, I mean, we start a model learning this whatever the AI ML model we have. So we start training this. So once we start training it, the continuously we do this regression. Regression is, I mean, there are like 10 test cases for this particular feature to work. So you continuously keep on running this 10 test cases for different output, different kind of output, input, and see the output. So the output should always be like whatever the human has done. So the same way it has to decide, and it has to give a meaningful output. So based on the output, you tune the inputs and you tune this KPI model. So you even tune the algorithm. So based on that, this continuous process is like until 99.9% of the times when you run, like for example, if you run for 100 times, 99.9% of the time it should give a positive output. So then that is called as a trained model. So once this is trained, then it will be tested in the real world, and that will be given as an output to the analysis team. So this is how a general like this is the learning process which is involved in the machine learning. So this is the example with specific to the spam filtering process. So out of this, like real world, there are thousands of agencies that will be sending us the ad related emails or loan related emails, or they have like some organizations who are trying to steal our data or the personal data from I mean, using Gmail. So they will be sending this emails to the email server. So here the measuring device is an email server. So this is kind of, you can consider this as a Gmail. So to this particular Gmail inbox, you will start receiving from the real world, and out of this there will be many emails that are important, and there will be many emails that we consider it as a spam. So we apply a particular algorithm here. So like if we want to filter out a spam email, so basically if we do it in our manual way, so what we do, like first thing is we see to how much recipients it is sent, the same email is sent, and we'll see the size of the message, whether it is too big or if it has something like unwanted characters which may seem like something is like they are trying to hack our data or something. And if we see any an attachment that is that we can, like, by seeing it, we can see it is a harmful attachment or something like that. And that too, I mean, how much persons have replied regarding this particular email in the subject line. So these are some of the, like, features based on which we can classify this, whether it is a spam email or it is a useful email. So this is kind of the feature selections we want to do it on this particular email server or the group of emails. So once we have this features, so based on this, we write a code based, I mean, from an algorithm. And then first is like, we will try to get first level of useful data, the useless emails, or what we consider as spam, or the noise filtering will happen in this. And then we will try to project it in a graphical manner. And then we will try to find out like which is the email that is having a maximum number of like at what particular date and time it will be usually sending their emails, and what is the organizations that are involved in it, or what is their email address, the domain IDs and everything. So once we have this, we will start building up a blacklist kind of dictionary. So that will, like, once we have this particular data, we will keep on adding this data, whatever we get, the domain names, the basically the email, I mean the email ID, whatever we are receiving, and we consider it as a spam, we'll start putting it to a dictionary. And then based on that dictionary, we will run this, like for example, this is my Gmail ID. I will try to run this code. This is model learning in the sense. So based on this all features, I have written a code, and this I am trying to run with my Gmail server and see whether whatever it is giving as output is whether really it is a spam, or if it is also trying to filter the important messages. So based on this output, I will be like tuning all the inputs and the algorithm and everything. So once I test it and once I get the result and whether it is proper, I will start testing it in a public way. So public way in the sense, Gmail by default, like it analyzes and decides some of the email is a spam, and it automatically moves it to spam folder. So if you go to your spam folder, you can already see some of the mails that is already moved here. So that is actual, like once it is trained and it is tested, it will go to the production. So that is where you see it as like implemented in the Gmail. So this is one of the example that I wanted to share. So this is again a high level architectural diagram of this same thing. So here, this is a database. It can be in any database. It can be Oracle database or the NoSQL database, or any database which has the email group set, like which with useful emails and the spam emails. So once we pass it through our learning AI ML model, it should classify based on like some of the features, whatever we identify, it should classify and give me whether it is a spam email or it is a useful email. So this will be the kind of output. And if you see here, this is one of the kind of graphs that we can see once it is plotted. So this is a kind of threshold. So what this threshold indicates is, so whatever that is there this side may be considered as spam, and whatever can be like there this side, maybe we can consider it as a non-spam. So if you see, no model is 100% efficient. So there will be some like mismatch even from the model itself. So if you see, like ideally it all falls, like all the spam messages are grouped in this particular section, but here one is missed. So that is where like you cannot have 100% accuracy with whatever the model you train. So we try to achieve the that is called as like in the industry they call it as 5 nines, 95.99999. So that is the at least like they try to achieve that much level of accuracy from a trained model. So the one more major application of the AI ML is the image recognition. So I think before we started this session, so there was some discussion already, which wherein Shashi was already showing that image and how we can read an image. So that kind of discussion is happening. So I think you already have a kind of idea why this image recognition is very important in this particular field. So if you see the like real world or a digital image, so there are a number of situations wherein a hacker will send you an image. It can be through an email or a WhatsApp or any normal message, wherein they send a multimedia message, and that image can have hidden encrypted messages and some of the codes that can steal your data from your laptop, or even delete the data from your mobile, or do a reset from your mobile, or install some of the things in the back end which you don't know, and record all the things that you can, like your call based data and your WhatsApp data. It can export to some other person in the back end. We don't know, like, all these things. So these all things can happen with image. So with image recognition, like what is the main advantages? It will try to see whether the image is like a healthy image, or it has some virus kind of things that is injected to it. So this process is called as injection. So it can be a SSH injection, SQL injection. So there are multiple injections that will be done. So this is an image injection wherein some of the malicious code is put into this image. Once you open it, it will, in the backend, it will gain the admin access and do whatever it needs. So if for example, we cannot, like, all these images, we cannot just directly see it, I mean, see it and recognize it, right? Like the color of it or any other things, that is, I mean, we can easily recognize it from the eyes. But this code and all, it cannot be done. So this AIML is also, like, it is first is used in to give, I mean, for any image, if we pass it, it will have this particular capability to recognize the colors based on the pixel segregation method it will implement. And it will also have this capability to also check if there is something malicious that is attached to this particular image that is being spread across. So these are all the different kind of things it can do with this particular AIML methodology. So if, like, if you see this one, like, if if you see a particular car, you can say based on the brand, it has the brand logo or the color of it. You can say what is the model of that and what is the color from the human eyes. So this is all manual. But for computer, everything is binary. It is zeros or ones. So it will be whatever the image we pass, it will be like divided into like millions of pixels. So it will be comprising of millions of pixels, and it will, based on each pixel value, so whether it is like what is the value it has, based on that it will I mean, based on the numerical value, it will try to read this image, and there will be n number of processing algorithms to process this. And like in the digital image, it will look for this particular patterns to process this, and then based on that, it will implement this AI ML learning machine algorithms to recognize what is that image. So if you pass a cat, it will show it as a cat. If you pass it as a, I mean, pass in a dog image, it will show it as a dog. So this is all happening because if, like, the image we send is split into millions of pixels, that pixel will be read by the code, and we have a particular algorithm to decide the pixel value, the color of it, and what image I mean, the particular pattern is representing. So all this will be read by the machine learning, and that will finally give us an output saying, okay, this is like, this is a cat or this is a dog. So this is how it is all working in the backend. And like one more this one implementation, if you, like, we have this face unlock, right? So how does the mobile know it is only our face it should unlock? So it is also one of the implementation of the machine learning, which we can see in most of the Android mobiles and even the iPhones. So the basic intention is the camera will capture your face, or it will see your face when you try to unlock it. And in, like, each phase we have multiple like nodal points. Nodal points is something like a feature. So maybe you can have a mark, or you can have, if you are wearing spectacles, or if like, there will be kind of different points which will, the algorithm will notice in a particular phase, and based out of that it will generate a unique key. So once, if you show, I mean, if we see the camera of this mobile, so it will, based on the image it will see, it will generate a particular code based on this different nodal points. And once that particular code is generated, so once we, like, when we initially record our face, right, when for the face unlock, so that code is generated, and when we try to unlock it, a new code is generated. So this code and that code, since it is all numbers, it should match. So that is kind of a key. So if we try to like show it to other person's face, it will automatically generate a different unique number based on the nodal points on that particular person's face, and that will obviously not match to the key whatever that is stored or whatever that was recorded initially. So that is the reason it will not open this particular phone. So that means that is how it is all working in the backend. And like previously, when this initial like versions of it came out, if you show a particular person's image, like a photo, physical photo, with that photo, the mobile was opening. But now it expects you to blink your eyes, and it expects you. I mean, if you show a particular photo of that recorded person, it will not open. So that is the like advanced applications that is also happening in the algorithms that is used, because they people were trying to, like, if a person is sleeping and if you just keep it in front of the person's eye, I mean, face, it was opening. So the algorithm was improvised in such a way that you should have your eyes blinking and you should have some movement in the face. So these are all the different points that were introduced later to kind of prevent this misuse of the unlocking feature of the phone. So these are all the different things that will be considered in the backend and how it will work in the mobile or anywhere, even in the laptops, we can see the face unlock these days. So the same applies even for the fingerprint unlock. So when you enter a fingerprint, it is nothing but a sensor. So the sensor scans the fingerprint and generates a number. So that number should match to already recorded fingerprint number. That is a kind of key value matching. So once it happens, if it matches only, then you will be unlocked. If it doesn't match, you will be like shown an error saying that the fingerprints doesn't match. So these are all the different kind of applications that we can see from the image recognition. So as you can see, there are multiple other image recognition uh, image recognition implementation that we can list. We see in the list here. So one is drones. So the drones is playing a major role even in the cyber security and the police force also. So based out of this drone, they are trying to monitor the remote areas wherein army cannot reach, even in the Kashmir side. So this is how like the AIML will like detect. These kind of drones are very much advanced drones, wherein it is not just a camera. It will have an infrared sensors. It will detect a person's movement, whether a person is like if a person is breathing. Based on that breathing, it will generate a pattern. The infrared can decolor it. I mean, color coding will happen, and it will show it as a different kind of image if a person is hidden, even in under a cave or under a tree or anywhere. So this kind of advanced drones are being used, which is using the image recognition technology. And the models, there are like thousands of models which are already present in the open source media. So it depends like what is the use case which we want to achieve. We want to search for a particular algorithm, and then we can choose a particular algorithm which suits our needs, and then we can start training it in our particular script. So manufacturing, if you see, all the most of the manufacturing is happening in an automated way. So even this, as you are all aware, this Ola Electric has come. So it has a 500-acre gigantic factory wherein every 2 seconds a scooter will be assembled by the robot. So this kind of precision is, seen only because of this AI/ML implementation, wherein it automatically sees if a particular thing is not proper, or how much like where are all the different components, how to assemble it, how to screw it tight correctly. So these are all the different things which are already implemented into a huge ecosystem of manufacturing sector. Self-driving cars. So this is one more use case. Maybe I'll like talk about this as a separate topic itself. So one more is there are also different use cases even in the medical field. So one is like there are X-rays that can, when a person takes an X-ray, so the X-ray has some of the minute components which are not seen to the human eye to decide if there is a cancerous cell or not. So these are all the different kinds of things wherein if you pass this particular X-ray to an AI/ML model, this image to an AI/ML model, it will pixelate this whole X-ray image, and it will say if there are some cells which are bound to be cancerous or not. So this kind of detection is also possible with the AI/ML. And so the handwriting recognition also we can do via this AIML. And one more, the major use case which I can remember is, so if you remember, like if there is a feature in our mobile these days wherein you just show it, like capture an image. If you open your camera and capture an image, out when you capture that image, if it is having some text characters, you can directly extract it. If you have seen it or not, I'm not sure, but this is one of the major like breakthrough kind of cases which is there. So like if we don't have to if there is a particular ad kind of thing and you capture it when you are moving in a phone camera, and if there is a phone number, you don't have to like see the number and dial it. So there you can directly extract the number from the image itself. So these are all the different applications that AIML is bringing to the feature, which is very much useful to the like latest technological world. So one more use case which I want to speak is the speech recognition. So this is one of the major use cases which is already like most of you are already aware with the Google Assistant or the Alexa or maybe Amazon Echo Dot, or the even iPhone, whoever is having the Siri AI ML assistant is also there. So so it will all work based on like it is mainly it is all a software application which has a trained a AI ML that is already built into this particular app application. So basically how it all does is, again, the speech, it will be because the computer or the laptop or the algorithm or the code will not know whose speech it is. So it will basically first record that speech, and once it is like recorded, it will generate kind of this kind of audio wave. So this is a in the back end, it will generate again like numerical values from the value, I mean whatever the voice you tell to it, and that based on that value it will try to search. It will have a kind of internal dictionaries wherein that if this is a value and this is kind of output we should give. So this is kind of a key value pair that is already stored in the database. So if you like open your any voice assistant, and if you directly say to it, it will script, I mean give you this as an output. So this is kind of an implementation which is trying to understand your voice and type that output in the mobile screen. So this is kind of like these are the advanced applications which is already like helping a lot like in this modern world. So one more is this medical diagnosis. So one is, as I told, the X-ray related, which I told earlier. So one more is it is also used in the diagnosis of many other diseases. So like one is this cancer related cells which can be detected using this AML methodology, and one more is if there are any tumors that is like starting within the skins or something like that. So this kind of tissue level analysis it can do. And like if there are any where the fluid is already like getting clogged. So these are all the different kinds of things. It is very much useful wherein if like the ECG or any machine, if you see, it is all kind of a semi-trained sorry, can someone mute?
మా 5 వస్తాయి.
Can you please go on mute? So this is the kind of advanced medical diagnosis which we can see. So whatever the CT scan you can see, or the ECG, the advanced ECGs which is there. So these are all different kinds of trained devices wherein it not only takes an X-ray or kind of takes that histogram, it also in the back end with this AIML trained model set, it will try to give us the more meaningful data wherein it can detect the cancerous cells. It can diagnose what is the like different reasons that can come for like a particular if there is a fluid that is being like accumulated. So what can be the reason, and what kind of fluid, or what can be the density of it, how much it is already spreading. So these are all the different kinds of useful output data that is giving, which is a kind of a breakthrough in all the different areas of the day-to-day life. So if you see, I try to cover this like image recognition that is used everywhere, medical diagnosis. So that is one of the major breakthroughs wherein where whatever the human cannot detect can be detected by some of the models that are being developed. So whatever the like heartbeats and all, we are all measuring with the smartwatches. So everything is again in the backend like code, and it all maps to a particular algorithm that is like a trained algorithm which is used in the backend to see. So if you see using the Apple iWatch, there are many cases wherein a person who is having a heart attack is being detected by the Apple Watch, and it automatically calls the emergency number, so that many of the times the person is saved. Because we don't know whether I mean, as a person, we don't know whether we really had a heart attack or it is just something like we are uneasy or something like that. But these are the there are scenarios wherein the watch has detected the medical emergency, and it has informed the notified person's list, and then it has saved the person. So this is like life ending life saving applications that is developed with the AI and ML that is already there. So, like as we move to the completely different domain, so one more domain that is implemented that is using this AI/ML is this statistical arbitrage. So arbitrage is like if you see the in the stock market or anywhere, so based on that there can be different types of groups that are trying to do false trading. So if you have heard of about this cryptocurrency, it is all algorithm. So it like if someone tries to steal, or if someone is trying to hack some of the data, or someone is trying to do some harmful things and steal the data from the web servers. So these are all the different kinds of things that can happen. So what this AIML, how it plays how it comes into picture in this particular example is, so this trading, whatever happens, the backend server will have an algorithm that is trained. So when the like if you like just consider our stock market as an example, so there are like lakhs of people that are trading together in different parts of India, and it is only a one backend server, so it is handling such huge set of data. So with such huge set of data, it is identifying the unique key attributes per user. So what is the PAN number, or the what is the unique number that we want to identify from this transaction. So based on this, the transaction will be processed. So if it finds something is missing or something is generated, or so basically it is all um, MD5 sum is like they will when they send it from their mobile, the request is sent from the mobile, it is being encoded and sent with a checksum, and that checksum will be verified by the backend server. And if the checksum matches only, then the transaction is considered as a valid. If it is not, then if there is some modification with respect to that payload, so then that the checksum will not match, and it will treat it as a some kind of malicious data that is trying to steal, and it will reject the transaction. So these are all the different use cases that we can see in the finance related field. So the next thing is the predictive analysis. So predictive analysis is like so whatever the data we have, so the first thing is we need to first extract the useful data out of the real world or the given set of data, and then we need to divide it into groups. So then based on the groups that is decided, so if it is a kind of group A, so it all goes to group A data. If it is a group B data, it goes to group B data. If it is a medical related data, it goes to group C data. So this is the kind of grouping, and then based on that group, we then apply some of the rules. Rules is nothing but the algorithm which we apply on this particular group, which will give a particular output. So what like the predictive analysis is where if as you are aware, so we are all seeing from the mobile that we can always see whether it will rain, or it is a sunny day, or what is the weather prediction for the next 1 week, 1 year. So everything it is happening through this particular AI ML model, wherein it is reading all this particular data which is already there, and it will read the data from the satellites, that is like an open API kind of thing. And based on that data, it will try to predict based on the latitude and longitude, this particular region, what is the weather? So what can be the weather next day, whether it can rain or not. So these are all the different kind of predictive analysis that the algorithms, the trained algorithms can do. So it is also used in the real estate pricing. So like for a particular area, what can be the price? So we don't know if we are trying to sell, we can have these kind of models are already there in the market, wherein you don't know what is the price that is running there and you want to sell your property. So based on your like the latitude longitude, you just give your latitude longitude to this particular website, wherein it says based on the data in like on the surrounding buildings and the buying and selling that has happened in the surrounding, it will be capturing all the data. So based on that, it will say what is the per square foot value, what is the best you can get. So these are all the different kinds of things that is very useful to the like day-to-day activities. So like the next one is the extraction. So extraction is again like we have a particular unstructured data. So unstructured data should be, I mean, we should extract some meaningful data out of it, and then it will be structured, useful data. So like if you see any data out there, which is like customer data or any email data, it is all very, very huge. So we need to have this and process this huge set of data, and then we need to extract some of the structured information from it, and then based on for that useful data, we need to apply a machine learning algorithm. So this is like general use case which is applicable in all the different models as well. So if you see, like there are some models which can even predict the vocal cord disorders, like based on how you talk. If there is based on the vibration the vocal cord generates, it can generate. There are some models which can already say whether if you have some disorder based on the vibration you are producing. And it is also helpful in like again preventing this kind of is also preventing in the sense first is diagnosis. Once the diagnosis is done, we can prevent it and treat it based on the diagnosis. So it is helping like in the the extraction algorithms which are out there are helping, which we can like this kind of extraction algorithms we can implement it to many use cases. It can be any use case, like it can be related to medical, it can be related to financial, it can be related to image related. So there are n number of use cases wherein we apply this extraction methodology, and then we extract the useful data and then apply a machine learning algorithm which will give us the useful output that is needed. So the next thing is the traffic alerts. If you have like seen this, if you just open a map and you give from place into place, it will show you the shortest route based on the traffic that is there. So this traffic and all is also like captured from the maps at the back end, and it is saying, so this is the shortest route you can go, and this is the other route which you can take, which has less traffic. So these are all the different kinds of applications which is which without the Google Maps. So if you imagine how difficult it was to move from one place to another place, or if we move to a newer area, so it was very, very difficult to go to any like surrounding neighborhood areas also. But now we can go even from state to state, district to district, without asking anyone, without stopping anywhere, with this kind of implementation of this AI and ML. So the like it will basically how this Google Maps will work is, so basically you have everyone like using their mobile will have a location sensor, and that location sensor will be updating their latitude and longitude. So that will basically give where you are present. So if it is continuously moving, so that indicates that you are traveling. So this all data from each person's mobile. So there are billions and billions of mobiles. So this all data from each one that is moving across the world, it's being sent into a particular database. So the database has to be very, very huge, and it is kind of a big data wherein we cannot imagine what is the kind of size of data there. So with this huge data, first is they will try to extract what is the useful data feature sets in the sense. So if it is India, okay, what are all the different states in the India? So that is first useful set. What within a state, what are all the different districts? So again, what are all the different kinds of roads? What are the different national highway, state highway? So this segregation will happen. Once this is again all a code that is written and a model that is trained in the backend. And once all that is done, with the real world use cases, like the mobile location will be updated to that. I mean, once it is all sent to a backend server, that backend server will process this data using the AI/ML trained model set, and it will give what is the estimated time or what is the kilometers that is there from point A to point B, and what is the traffic at this particular road. So the traffic density is again calculated by how much number of mobile devices are there particularly in a particular road. And if it is like, if it is not moving and if it is stalled, so then it treats them as like it is a busy road and the traffic is not moving. So these are all the different kinds of meaningful applications which has helped the humanity in a very, very drastic manner, I would say. So this is one of the major use case that is the like one of the major advances of the AI/ML we can see. And one more area is the surveillance area. So this surveillance, as I told earlier, it is used in the army related surveillance. It is also used in different kinds of surveillance, like the theft. It cannot be only copper, it can be anything for that matter. We can install this surveillance related systems in the house. It can be it is already present in the ATMs, it is present in the malls, anywhere and everywhere. You can there is no limitation for this these days, because you can see this CCTV and all the things everywhere almost. And abnormal event detection. So as I told, it is not only just for capturing and recording the images or the videos, it will capture some useful data and identify if something is wrong. So it will, even though it is night, if there is no light movement based on the infrared rays, and it will try to see like if it is an intrusion or if it's trying to like come in at what time. So based on all the different things, it will like raise a particular alarm kind of things. So these are all the use cases which is implemented with the video surveillance, sorry. And then facility protection. So it is again, as we can see, it is all present in all most of the public buildings and the traffic signals. So it is to protect the facilities, that is that. And the monitoring is also the same thing. If you see in the railway station, bus stands, everywhere, it is all like the video surveillance is already present to monitor the operation of the parking lots, to see like to ensure that uh, your vehicle will be safe when you park it. And then the traffic monitoring is kind of you can think this as two ways. One is, if you see the FASTag related, so it is all like so fast now, we don't have to physically spend the time in the toll gates paying the money and then taking the change and then moving. So it is all surveillance cameras that are installed. That is a higher surveillance camera which will read the barcode that is there in your car, and based on that, it will identify what's your number, and if you have balance in it, it will automatically deduct it and then like automatically send you within 1 or 2 seconds. So this is the kind of speed it is. Like we can see with this AI, I mean the trained model set with respect to the surveillance of toll booth. And then the shopping patterns. So maybe shopping patterns, I will talk this in a particular separate slide. So next we can move to this product recommendation page. So this is one which most of us have directly or indirectly seen this, but may not have noticed it in particular. So if you go to any e-commerce, whether it can be Amazon, Flipkart, or anything, you can, if you search a particular product in that in the website, and you can see already, we can see that customers who viewed this item also viewed different kinds of items. And the alternatives, like if you are searching for a particular purse, and different kinds of alternative purses from different brands, and who the brand who has paid like a premium price to the Amazon for like listing in the top. So these are all the different kinds of things which we can see. And not only within the application, if you go out again and if you search in the Google something, so even in the Google search, some ads will be seen. So that ads will be based out of what you searched in the within the Amazon. So this is the kind of data that they are extracting when we are browsing, and that is being shown to us. So like this is where like we try to search for a particular product and then we start seeing it everywhere, and then I mean, even though we don't want to buy it the first time, when we start seeing it continuously and the different recommendations of the product, different versions of the product, different competitor products that we can buy, so it is like continuously luring us to buy things. So I mean, when we start seeing continuously in all the websites which we are using, definitely, oh, that the tendency, the human tendency is like, okay, we'll buy it. So this is the like one of the major use case that is used in the e-commerce related domain, and it is also used in the YouTube. So if you see a particular like for example, you can, if you watch a particular bike or car related video, so like when you come back you can see only the bike and car related suggestions continuously. So if you start seeing something else, if you start seeing some course related videos, you start seeing only that particular kind of thing when you open YouTube. So this is kind of based on what you see and what you are interested, and that at that particular point in time, it, it will start showing the recommendations based out of it. So that way they can generate the revenue from your data. So they are, it's a, the data is the powerful thing here, which they are trying to use it, extract it, train it using some AI/ML models, and then make money out of the data which we are continuously using. So this is the kind of application that is used in the e-commerce. And one more is the chatbots. So previously, if we want to like generally, if there is if something is not working, so the first thing is we need to call the customer care and wait for them to come back and all. But now, if you see, most of the websites will have a chatbot. So chatbot in the sense like it will have a kind of database of general questions that will be asked and what kind of answers it should give. So it is like replacing a human itself. If a human is typing, if we want to, if I type something and if I ask something about my order, it will automatically say based on that order number what is the status of it. So it is I mean indirectly. It does not require a human to be manually present and do it. So the machine itself is understanding what the user is saying, and based on that, the actual I mean output is being given. Like a human is, it feels like a human is replying the, I mean giving the reply to the queries we ask. But so that is the like major application wherein they're automating everything and using this chatbot, wherein it will be like a faster turnaround time for the user to get the details he need, and for them it will be kind of reducing the human effort and reducing the cost from that. So if they have a script and that is trained, it is like 10 people whatever they are doing, maybe 5 they can keep, and 5 other 5 they can be redirected to this chatbot. So this is where the human resource utilization is also being optimized, the cost is being cut down, and the advancement is being happening in this particular domain. So this is one more like very safe. I mean, very useful use case wherein you, if we go to a different country or a different wherein they speak a different language and you are not able to do it. Previously it was very difficult to even communicate for the basic things, for even to buy the basic needs whatever we want. But now this Google Translate, so it basically it uses this particular algorithm in the back end, wherein you can select what is, it will auto detect whatever the language you speak, and you can select what language you want the output in. So you can speak in your language, and then it will I mean it will give the output of the language which you are intended, which you have asked for in this drop down. So that way you can communicate anywhere in the world even though we don't know anything. So at least to buy or to, I mean for the basic needs whatever we want. So this is the kind of like comfort it is giving, because without this, if we cannot even imagine to communicate with I mean with people who doesn't understand our language. So the language barrier itself is kind of like erased with this technological advancement in the AI ML field actually. So the next one is this video streaming application. So most of you might already have this Netflix, Amazon Prime, to stream your videos. And even like most of the TVs are I mean, the smart TVs have this particular thing, I mean, app kind of installed in the TV itself. So these are all the different online streaming platforms. So if like based on the genre you search, like if it is a thriller movie or if it is something like comedy movie, so based on whatever you search, it will start, I mean, giving you, it will start giving you suggestions, so that even though you wanted to like see one film and you want to come back, it will start giving suggestion in such a way that you want to like spend most of the time there only, so that they can like leverage the revenue part from your side. And so like that is the kind of push it will be having. Like we like we want to only as like kind of a social interaction or kind of a um, social time, we want to see one movie at a time, but it will make us to watch continuously one after the other. Like the suggestions will be in such a powerful way, that is using the AIML modeling, wherein whatever you are trying to search, the same things whatever you like, it will start giving you as you can also watch kind of things. So this is the kind of the powerful which is like powerful implementation, wherein it is even impacting the human behavior is also, I mean, it is trying to understand and how you can be like made to watch more of this like they basically they want to spend more time on the app or the platform for the revenue purpose. So it is even more modifying the human behavior to like continuously watch these kind of things based on the AML methodology that is there. So it all depends on what is the consumption of the AIML, but the use cases are like n number of it. You cannot even imagine. So this is the kind of I mean, one second. This is the kind of use cases that is there out, I mean, out in the field, if you see as an industry and the applications in the real world. So this is one more like major breakthrough which is already there in the US, and it is already kind of there in India also. So the autonomous cars, you don't need to drive. So these are all like very helpful features, wherein like you don't have to, even though you're not driving, you don't have to accelerate, you don't have to change the gear, you don't have to do anything. Basically it will automatically steer it based on the lane. So it is also using like image recognition and the video surveillance. So basically it will, each road will have this particular lanes, right? So based on that, it will, once you are in a particular lane, it will try to keep up in that lane, and it will have this particular sensors wherein what speed you are going, what the speed the car which is in front of you is going, and whether if anyone is coming to this lane, and when it comes, or if you're going too near to the car which is there in the front, you need to break down, or I mean you need to apply brakes, and then if it is far, you need to accelerate. So all the things is happening in the back end, which like wherein this is like saving many of the lives. Like previously, if for example this truck drivers or any of the drivers who are driving continuously, or even the human, uh, they might fall asleep in between due to continuous traveling. But with this autonomous cars and the technology that is developed from this AI and ML, so in the back end, what will happen is, even though you fall asleep, it will automatically detect you have fallen asleep, and it will give you an alert. If you like, if you don't blink your eye for more than 5 seconds, it will give you an alert, like, or an alarm within the car, like saying okay, you're falling asleep. So that and even if you fall asleep with the alarms also, it will automatically control your steering and the car for you, and then it will park it in a like safe way, so that it can avoid accidents, it can avoid save lives basically. So that is the greatest kind of a breakthrough or helpful thing that is that we can see from this AI and ML methodologies that is there. So yeah, the example I can take is the Tesla, which is there in the US and which is already coming to India. And even in the Indian cars, that is Mahindra XUV 700, the Bosch sensors or the technology, whatever they are using, the car will have this particular AI and ML related uh, intelligence wherein it detects whether a car, like it will automatically apply brake, even though if a car in front of you suddenly brakes and you in panic, if you don't brake also, it will automatically detect that braking of the car in the front, and it will brake your car also. I mean, apply brakes even within your car, and it will like automatic steering is also present in the XUV 700. So these are the kind of technological advancements which is happening with the AI and ML, which is really saving lives, I can say. So this is one more like use case which most of us have already seen. So I mean, this Uber, Ola, they have this AI ML model wherein they can understand whether, like, if it is raining, so if it starts to rain, most of the people will use cab mode. So if basically what they do is at a particular time in a particular area, they will know what is the like minimum number of cabs that will be booked per minute. And if it crosses, like for example, if per minute 10 bookings usually happen, if it rains or if something happens, so or you usually it is in raining, or if some festival is there, or if some like market kind of thing is there, so which happens monthly. So per minute, if the booking crosses maybe 15 or 20, so automatically it will have this model where it detects there is a surge in this particular location, and automatically it will increase the fare to twice. So when someone is again like trying to search from go from here to somewhere else, automatically the price will be doubled, because the cab like running within this area, or the booking within this particular area is very much higher. So based on this AI ML methodologies, automatically they will detect whether more number of users are booking here, and based on that, they will try to increase the price. And then, so that is how they are like leveraging the AI ML in generating the revenue with this kind of particular model. This is called as search pricing. So this is like, and if the if like for example, as I told, if the minimum cars that is running is 10, maybe you can keep that as a threshold. And if there is only one that is running, so at that time it will also apply this particular model where it will give discounts for you. So since there is nothing running here, so they want to keep the business running, so they will give discounts for you, so that you start using this particular service. So that way, even if it is low, they start using some model and make their business run. Even if it is high density booking, they will leverage AIML again and the data analytics, and then use it for the doubling the price of whatever we are seeking. So whatever, as I told, I mean, till now, whatever as I explained the real use cases, if you see, so basically machine learning is nothing but we have a huge set of data, and first is we need to extract it something useful set of data, because we don't need all the data to be sent to the training model which we have developed. So first thing is to extract the useful data and eliminate the noise. So that is where the first thing comes into picture, that is called as data science. So data science is a kind of bigger tree, and within this AI, ML, and the big data. So these are the different kind of subtree within the data science. So data science is the huge kind of root that is present, and there are a number of branches to this particular field that is there. So basically, I mean, as I explained in all most of the examples, it is a complex study of the large data set that is there. So if you just consider Google as an example, it is like billions of users that are using it. So that much the level data has to be processed, and then it has to be then fed into a AIML model, and then a meaningful output will be generated. So data science is a field which is the parent of like kind of or AIML is kind of a child for this data science domain. So data science is nothing but out of the huge set of data, how can we, using some mathematical algorithms, how can we extract so a particular useful set of data and then group it, and then we can once the data is structured and then grouped, that will be fed into the AIML model to generate a meaningful output. So, I don't want to confuse you. Or the only thing is, so data science is like, first is when we have huge set of data, we need to first make it as a structured data and eliminate the unstructured data. So this is where data science is being used, and the algorithms that will be developed in this particular domain will first handle this huge set of data and then generate a structured data. And AIML is the subdomain wherein it uses this structured data and takes it as an input to the model or the algorithm which it has, and then trains it, and then whatever the human might have done to that particular situation or the output, automatically the AIML model will do it without the human intervention. So that is where, like, I want to like make you understand what is data science and how it is kind of a subfield of how AIML is a subfield to this data science, and how data science, the data is being segregated and how it is being fed to the AIML in the pipeline. So this is what I want to like make in this particular in this slide. I want to just brief you and explain you about this particular thing. So machine learning is again like, we are giving the computers to the capability to decide and learn based on the situation what has to be done. So if it is just a data science, it is only segregating the data, but the AIML will take that segregated data and then apply the useful modeling algorithms that is there, and then train that data set and then give the output and predict the output. So the predictability is the main thing that is coming with the AIML that is there. So these are all the different kinds of use cases and the different kinds of topics I wanted to cover today. And one more thing is, so since most of you are more like maybe in the final year and are graduating, so I would say this is one of the hot skill or the key domain that is being seen, and that is seen in the industry these days. So, and like if you end up your career in like a data science related domain or AI ML related domain or any other domain or related to this, so you will have a very very bright career, I would say. And one more thing is, like, you might like when you see all these things or when you see the code initially, you might all feel it is all very like very difficult, or it can be like something complex, but it will not be very much difficult or complex as you would say, because whatever the problem you have, most of the things, there are some things which is already available, someone have already developed it for you. So only thing is, you need to understand what is the problem is and what kind of algorithms you can apply to it, and you can search that particular algorithm, and then you can, it is all like a puzzle. So everything is there for you. You just have to mix and match these things and then join these pieces together to form a particular model. So you don't have to like feel like it is very difficult or it is very complex in the when you see it or when you hear it. It may feel so. So what I would recommend is, first is you have your basics right. So first thing is, you start with Python. Python is the one of the like most hot skill kind of language that is there in the industry. So you can end up as a software developer, you can end up in the testing domain, you can end up in the business analysis domain, or you can end up in the medical related domain, or the telecom domain. Anywhere you can end up in the networking domain. So everywhere Python is one of the like a language which is used across for automation. So if you are a developer, you write code it, I mean, you develop with Python. If you are a tester, you write code in Python to test a particular feature. So everywhere it is being used, and the AI ML, most of the things are being written in the Python. So I would suggest, first thing is, start with the right basics. So first is, learn Python as much as you can, understand it. There are n number of courses in like Udemy, Coursera, or anywhere wherein you can like, first is understand Python, take some courses, do some hands-on. So what I would say is, like, take some basic things or basic examples or basic problems which you have, and try to solve it from Python. So you don't like, that way you will understand what, at what situation, what are all the different things I can implement, what are different things I can, like, I should keep in mind, what are the different data structures that is involved in this, what is the different kind of looping functionalities. So this all, once you are comfortable with it, I would suggest you to take up some AIML courses that is already there with pre-certificate, like certification. So this certification, I would say, it will be very helpful to your career, because with the certification, if you end up like in any of the big companies or even in the small companies, if you end up in this particular domain, the financial growth or the skill set growth is very, very huge, uh, compared to, like, if you are even like 2 years experience, the income or the financial wise or the technical side for this particular domain, I mean, the requirement is very much, and the people who know it are very, very little. So you have very much opportunity in this domain. So I would like, what I would suggest is, everyone, you can consider this. You don't have to be scared, or you don't have to be uh, uh, like take a step back and like think it is not for me or it is very difficult. It is all, it may seem difficult, but once you start from the basics and start step by step, you can easily do it, as anyone can. And once you have that particular set and like tool set and the skills, and once you have that confidence, definitely you can be like, whatever is your dream, definitely you can go with your career dream. That is what I would want to say, and maybe that is all I had for today. So if anyone has any questions or anything, maybe can ask me. So I hope no one has any question. Maybe we can wind up this session. Can someone like acknowledge whether am I audible?
Yes, sir, audible.
Yeah. Okay. Okay then. Thank you all for this opportunity to share whatever it is that the industry is like industry is presently, what is it is looking for, and what all opportunities you can have, and giving me an opportunity to discuss this with uh, different kind of faculties, and then different kind of students. So I wish everyone all the best for their career, and thank you.
Rakesh sir, thank you very much.
Yeah, thank you, sir.
Thank you very much, sir. 1 minute, we have photo session along with you.
Yeah,
I
yeah.
request all the participants, please turn on your video.
Mummy. Marble chokila. Mummy. Mummy. माउस बंद कर मम्मी मम्मी बोलना मम्मी मम्मी ऑन करो